Let's finish the argument that z to the power p over q has exactly q different values. Our main assumption is that p and q are relatively prime. We know that z to the power 1 over q has exactly q different values, and they are equally spaced on a circle of radius r centered at the origin, where r is absolute value of z raised to the power 1 over q. To get z to the power p over q, we have to raise every one of these to the power p. And since p is an integer, and raising a complex number to an integer is single valued, therefore we cannot get more than q values for z to the power p over q. But the question is, why can't we get less? In other words, why can't two of these be the same when raised to the power p? The absolute values will be the same, r to the p, r to the p. What about the arguments? Each argument is multiplied by p. So if they are the same, then we get p times theta plus j plus 2 pi over q equal to p times theta plus k times 2 pi over q plus 2l pi, where l is an integer. Here k and j are two indices. For example, here each one is 0, here 1, 2, 3, and so on. In this position, j or k is q minus 1. But then if we add another one, we go back to the original. So j and k must be from 0 to q minus 1. Now, let's do a little bit of algebra. Multiply by p, and then cancel the p theta with p theta, and we get pj times 2 pi over q equal to pk times 2 pi over q plus 2l pi. Divide both sides by 2 pi. We get pj over q equals pk over q plus l. And then subtract this term from both sides and factor out the p and combine them into one single fraction. So p times j minus k divided by q, this rational number equals L. And L happened to be an integer. So therefore the left side must be an integer. So we know that q and p are relatively prime. So the only factor of q that divides p is 1. Therefore, the whole q must divide j minus k. And what's wrong with that? J and k are from 0 to q minus 1. What do we get if you subtract two different values here? The difference in absolute value would be less than q. And how can a number with absolute value less than q be divisible by q? That's impossible. Unless j and k are the same, which means this is 0. Every number divides 0. So there it is. So no two of these roots after raising him to the power p would equal. Therefore, z to the power p over q would have exactly q distinct values.